For the circuit diagram in the figure below, showing admittances all given in Siemens and current sources at nodes 3 and 4. A. Set up the KCL equations in matrix format according to what was seen in class by inspection. Part B. Compute the four nodal voltages V1, V2, V3, and V4. And C. Compute the active and reactive power through the link between 3 and 1, from 3 to 1. The first thing I'm going to do is to copy the values of all of those admittances in Siemens into the diagram, commencing with y sub a negative j is 0.8. And now we are ready to write the KCL equations in matrix form by inspection and according to what was seen in class. The unknowns of the system are, of course, V1, V2, V3, and V4. On the right hand side we have the total current entering node 1 from current sources, which is 0, and for node 2 0 as well, and for node 3 1 with 90 degrees, 1 with 90 degrees, and for node 4 0.62 with negative 135 degrees. Now let's go for the terms inside the matrix. We say for node 1, 1, we have the sum of all admittances connected to node 1, that is negative j4, negative j8, and negative j2.5. That would be 8 and 4, that is 12, 14.5. That is negative j 14.5. That is the first term we find in there. And we have the system of equations that is asked in part A. Now compute the four nodal voltages V1, V2, V3, and V4. Just enter that into your calculator and solve for it. Let's do that. Those are the three voltages we're looking for: V1, V2, V3, and V4. Those are the four values for V1, V2, V3, and V4 from the calculator. Now for part C, we need to compute the active and reactive power flowing through the link between nodes 3 and 1. That is the power flowing through. I will validate it as correct if you compute the power entering this link from bus number 3. That is a voltage V3 by the complex conjugate of the current flowing from 3 to 1. Let's compute that current. We compute first the current flowing from 3 to 1 through the link, and then the power that flows from 3 to 1 and that leaves bus 3, that is the leaving bus, and the power that arrives in bus 1 coming from the link 3 to 1. The numerical value of the current through the link between bus 3 and 1 flowing from 3 to 1 is given up down here, and the power flowing from 3 to 1 arriving in bus 1 is this value, and the power S313 flowing from 3 to 1 leaving bus number 3 is this value. Observe those power flowing through the link 3-1, the one that arrives in bus number 1 and the one that leaves bus number 3. The first thing we notice, and no surprise there, because there is no resistive component to that link, is that the active power is the same on both sides. Negative, that means that it's actually flowing from bus 1 to bus 3. So we have 117 milliwatts flowing from 1 to 3 through that link. What about reactive power? Well, the reactive power that arrives in bus 1 coming through the link 3-1 is 84.9 millivars. But the reactive power that goes through that link leaving bus number 3 is 111 millivars. 111 leave bus 3, but only 84.9 arrive in bus 1. So the ones that flow from one end to the other are 84.9 millivars. That is a reactive power that flows through that link between bus 3 and bus 01. 117 milliwatts flowing from 1 to 3 and 84.9 millivars flowing from 3 to 1. How is that again about millivars? Well, imagine a situation like this. You have a bridge that is a YC, and you have soldiers that you are sending to cross the bridge. You send 111 soldiers to cross the bridge, but at the other end of the bridge only 85 of them arrive in. So the ones that actually cross the bridge are 85 soldiers. So that is the power that flowed through that link. 84.9 millivars flowing from 3 to 1 and 117 milliwatts flowing from 1 to 3. However, in the exam, I told the marker that if you compute either of those two powers, this one, the power that arrives in 1, this one, or the power that leaves bus 3 through that link, and those values are correct, you get full marks for that part of the question. But for your future, remember what is the actual power that flows through the link is the one that leaves one bus and makes it all the way to the other one, to the far end. And with that, we have completed this exercise. Thank you very much.